Alright, so theorem number one. This one's quite important, just like the rest of them. And we have to remember that theorems become tools for us. They help us deconstruct geometric shapes that we're presented with, and especially in Euclidean geometry, we're trying to find, even though the problem may ask for one unknown, we're actually trying to look for all of them, because that will eventually help us get to those points that we want. So theorem number one can be stated in a number of ways. In words, this is where I spoke about subtending as well. The angle subtended by a diameter within a circle, sorry, this is a little circle I've drawn, equals 90 degrees, or it's perpendicular. So what does that mean for us visually? Well, let me draw a nice circle. You'll notice that none of these circles I draw are really circular, but I hope you'll bear with me and have a lot of imagination. So what we're saying basically is, if we are able to draw a diameter within a circle, line straight across, or it's equal to the two radiuses, the two radii. Okay, if I can now turn this into a triangle in any way, then wherever this point is that is being, remember this angle now, because we have one ray and two ray going across a line segment, or in this case a diameter, I can now say that this angle, let's say if we call it angle A, I can say for sure that angle A equals 90 degrees. Okay, and that's what theorem 1 states. So that seems a bit magic. How do we prove it? Because knowing a theorem is good and all, but we have to know where that really comes from. So let's break down this theorem. Okay, and it's important to note that I can shift A, or this point, anywhere along the circumference, because it will be subtended anywhere along the circumference, and it's going to be perpendicular. It will be equal 90 degrees. Okay, so let me erase some things to get this proof going. Okay, so I've left an important piece of evidence. We're starting out with, from a circle, we have two radii, and if I'm going to shift this, I'm going to draw this circle here. Oh, sorry, I'm drawing no circle, I'm drawing this triangle. So I have a triangle, and I can add a third line from the point that's been subtended to the center of my circle. And I know now, once again, because of the properties of a circle, that this is equal to the radius. Okay, so that is an important feature now, because what can I say? Well, if I'm to look at this triangle over here, I can see that this is an isosceles triangle. If I look at this triangle over here, I can say that this is an isosceles triangle as well. Okay, so that means that if I was to label this triangle, maybe let's call this triangle, give these angles A. I know that angle A is going to equal angle A in the corner here, because this is an isosceles triangle, two radii equal. Likewise, I can now look and say, well, within this triangle that's been formed, I have an isosceles triangle, because the radii are equal once again over here, and I'm going to call this guy B. So I'm going to have B and B. Okay, so now I know that the two A's are equal, the two B's are equal. Now I can look at this triangle in a bigger way. Okay, so I can look at this triangle, these two triangles, as one big triangle. Okay, and that means this big triangle has three angles now. It has A, B over here, and the third angle is A plus B. Okay, so let's get the maths going then. Okay, from this we are trying to prove that this angle, we're trying to prove A plus B equals 90 degrees. Okay, so let's jump into that. I'm going to come down a little bit. So from this point over here, if we're looking, let's get the maths going. So I know now that A plus B plus, and this guy is kind of, if we look at this as one big angle, this is A plus B, and these all equal 180 degrees, and that's because this is one large triangle. So we can now expand, because we know that the 180 degrees from the angle sum of a triangle, so we could now clearly state that A plus B, I can drop this bracket, I can collect terms, I've got an A here, and an A here, a B here, and a B here, so I can now say that A 2A plus 2B equals 180 degrees, okay? And from that, now, I can collect these terms, can kind of take the 2 out, I can factorize it, so I know that 2A plus B now equals 180 degrees. And if I'm to now solve the equation a bit further, I can divide. So I'm going to divide this side by 2, I'm going to divide this side by 2, okay, because I'm trying to get rid of this top here, so what I do to one side I have to do to both, so 2 goes here, and I end up getting A plus B equals 90 degrees. Well, that seems like an interesting point, because A plus B, which we have up here, A plus B, that equals 90 degrees. And so we've proved, for generality's sake, that we also call that angle A. We now know that angle A, this angle that's subtended, is always equal to 90 degrees. So, huzzah, there is our first theorem done.